Hello everyone. In this video I want to make a clarification in how to use the truth table to test for valid and invalid argument. So first than anything, is important to just double check that we have the definition of how to check the validity here on the summary 2.3. And it's here testing an argument form for validity. And so we only going to refer to the truth table. We're not going to refer to the method for tautology. So be careful with that. The method with tautology requires that every single entry on the final row of the argument is true. Okay? But now here we want to do something more shorter, and so we're only going to check for critical rows. Okay? So let's just really quickly go ahead and define the critical rows and also the type of arguments. So you're going to have an argument, and the argument has premise 1, premise 2, and then you're going to have a conclusion. Okay? And so what we're trying to do first is, of course, we want to identify who those premises and that conclusions are in the form, and we want to construct a truth table for each of these premises and the conclusion. So for example, we're going to have many different things, and maybe you need more parts, but let's say that you construct a truth table with P1, P2, and then the conclusion. Okay? So one of the things is, like, we need to establish what is a critical row. So critical row is when all the premises are true. So you have here, let's say, true and true. Okay? So at that point, that's a critical row. So the argument is going to be valid if and only if every time that you find this true and true critical row, then you get the conclusion being true. Okay? So as long as you find this true, 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 then you're ready. You're good for every critical row. But let's now check some different things that can happen. So if you get false and true, and then you get true, that doesn't matter. That's not gonna help you prove, but it doesn't matter. It doesn't contradict the validity of the argument. If you get true, false, and then you get true, then that doesn't matter either. That doesn't invalidate the argument. If you get, let's say, true, false, and then you get false, or you get false, true, and then you get false, none of this is going to matter. Okay? The only problem comes when you might get this. You get true, true, and false. If you get that your critical row is producing you a false conclusion, then that's going to be the moment that the argument is invalid. Now remember, this is coming from the P implies Q. And in P implies Q, when was this false? This was always true. And it was only false on the case when this was coming from true implies false. If I have true implies true, that was fine. If I have false implies true, that was fine. If I have false implies false, that was also fine. But it was not okay when we have true implies false. And that's the only case where an argument is going to be invalid. But now, so this is the potential problem. So now, when we want to prove an argument, we need that every time that we have a critical row, which is when the premises are true, only the premises, so that's why I'm highlighting this, when the premises are true, then you get true. So if you get your truths, then that's fine. And so let's give some examples here on when that's going to occur, and let's use some of the examples for that we're missing from invalid arguments to complement. So first, let's give the first argument that we provided. It was we have P, Q, and P implies Q, and then we were given, okay, so if we have P implies Q, we have P, and then we have Q. And so here, this is going to be my premise, premise to conclusion. Okay, and this is going for the if P implies Q, and then you have P, that you can conclude Q. So we have true, true, false, false. We have true, false, and then the implication again is always true unless true is implying false. So we have this. Then again, we repeat here what are the values of P and Q. So let's search for our critical row. We only have a critical row here, which is this one, and notice that the conclusion is also true. So we're fine, and this is a valid argument. Okay, this is the modus ponens. Now let's do a second example. I left the modus tollens before to you, but let me just go ahead and actually do that. So let's say number 2, I have modus tollens, which is, let's assume that I have P implies Q and I get not Q, so the conclusion is going to be not P. So now I have P, true, true, false, false, and then Q, true, false, and then of course I'm going to need negation of Q, which is false, true, and negation of P, which is false, false, true, true. So now P implies Q, and so this is going to be true, false, true, true, and I'm gonna rewrite negation of Q, since this is going to be my premise number 1, premise number 2, and now my conclusion, negation of P. So premise number 2, again, this is going to be true, false, and negation of P is going to be false, false, true, true. Okay, so at this point, notice that let's wait a minute, I have this wrong. This is negation of Q, this is false, true. Okay, negation of true, false, true, false, true. And this is false, false, true, true. Okay, that's correct. So let's look for a critical row. So we don't have critical rows here. We have a critical row here on the last one. This is my critical row because my premises are true, and now my conclusion is true, so I'm good. Okay? I don't have anything else, and I don't have any other critical rows, so I don't have to worry, and I don't have anything else. Now let's give other couple of arguments that work out. We have the generalization and we have the simplification. So let's just go and do those, and then we'll jump to some examples of contradictions or invalid arguments. So we know that if we have P, we can conclude P or Q, which is the generalization statement. And this is just simply you have P, true, true, false, false, and then you have Q, which is false, true, and then now you have P or Q, and P or Q is always true unless they're both false. So this is true, true, false, false, true. I did it here backwards, false, true, but that doesn't matter. It's fine. So now notice that I want to do the argument. So if I'm going to do the argument, I should probably just do it again. Write P here. True, true, false, false, and then write the conclusion. So I can write premise, conclusion. And so when I have this single ones, then the critical row is only going to be my one premise. So this is a critical row, this is a critical row, but because it's true here and true here, then we're fine. This is gonna be reflected in here, and then we have that this is a valid argument. Okay. Now let's jump to do a couple of invalid arguments. So we have one that we did in class plenty, that it was the one about if I win the lottery, then I'm rich, then it's because I won the lottery. So that's something of the form P implies Q, then I get Q, so I conclude P. We know that that one is wrong. Okay, so we're gonna show that that is incorrect. We have P true true, false false. Q is gonna be true false, true false. And so now I'm gonna do P implies Q, which is gonna be true, false, true, true. And I'm gonna give Q here. This is my premise 1, premise 2. This is gonna be true, false, true, false. And so notice that now my conclusion should be P, which is true, true, false, false. Okay. Notice that I have two critical rows. I have this critical row here, and this is giving me true, 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 true. But this critical row here is giving me true, true, false. So the problem of this is that I have two premises implying that the condition is false. So in this case, this is going to be an invalid argument, just because I found one of the critical rows that gives me a false conclusion. I cannot have true implies false. Okay. Now let's do another example of invalid argument. We have the P implies Q, and I have not P, so I'm gonna conclude not Q. So this is P. Again, true, true, false, false. And then Q, true, false, true, false. And then I can go with P implies Q. P implies Q will be true, false, true, true. And then now I'm going to go with negation of P. Negation of P will be false, false, true, true. And this is going to be my premise 1, premise 2. And the conclusion is going to be negation of Q, which will be false, true, false, true. Notice here I have the same behavior. I have a critical row that is all true, but I have a critical row that is true, true, false. So because I have this true implies false, this is gonna make my argument invalid. Okay. So the problem with invalid arguments, or what happening with invalid arguments, is that you're gonna have this one shows up. The true implies false is going to show up. Even if I have the premises being true, if I get my conclusion being wrong, that immediately is going to mess up my argument. Okay. So let's give one more example of valid and invalid argument. Let's go with transitivity. And transitivity might be a long one. So let's do this one. Let's do P implies Q, Q implies R, so conclusion R. This is some sort of transitivity here. Alright. So I have P, and so I have true, 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 false, 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 and I have Q, which is true, true, false, false, true, true, false, false, and then R, true, false, true, false, true, false, true, false. So this is quite long. And so we have P implies Q. Q implies R and R. So P implies Q. So we have true implies true, true, true implies true, true, true implies false, false, true implies false, false, false implies true is true. So we complete all the A values. Now Q implies R. True implies true, true, true implies false, false, false implies true is true, false implies false is true, true implies true is true, true implies false is false, and then we have the other two are true. Okay, and then we have R, which is true, false, true, false, true, false, true, false. Okay, so this is very long. So now we can see here that we have the row, the critical row with premise 1 and premise 2 having a conclusion that is true. So we're good with that one. And notice that the other critical row that I have is this one. But this is true, so it doesn't matter because it's not giving me a false. Same with this one. So this is a valid argument. Now let's do one last invalid argument. So let's go with P implies Q, and then this is premise 1. Premise 2 is going to be negation of P implies negation of Q, and then conclusion negation of Q. So again, we have P true, true, false, false, Q true, false, true, false. We have P implies Q, true, false, true, true. Well, I need negation of P implies negation of Q. So let's do negation of P here, false, false, true, true. And then negation of Q, false, true, false, true. So negation of P implies negation of Q is I'm going in this direction. So false implies false is true, false implies true is true, true implies false is false, and true implies true is true. So I have my premise 1, I have my premise 2, and now I want to get to my conclusion, which is negation of Q. So this is false, true, false, true. Now let's look for critical rows. Critical row here is going to give me true, true, false. So I immediately know that because this one is showing up, this is invalid. I won't even need to to check anything else. If I notice that this is showing up, then I know it's invalid, although you can find that this one is in here. Okay, so for invalid arguments, you just need true, true, false to show up, or true implies false to show up. True premise, true implying a false conclusion, then it will give you an invalid argument. For valid arguments, you will need that every single critical row where all the premises are true are going to lead to a true conclusion. It doesn't really matter what else, what other combinations you have between the premises, because they're not critical rows. As long as you follow the idea that for every critical row, everything has to lead to a true conclusion, then it's fine. Okay, so hopefully this more in depth, more examples here serves to clarify doubts between how to address that and how to work on the particular question from the quiz. Let me know if you have any questions.